Welcome. I hope everybody can hear me. I'm getting a nod, maybe. Good. My name is Jeannie Bertrand. I'm the Vice President of the Recycling Council of Alberta, and I wanted to welcome everybody and say thanks for joining us today. I'm the project sponsor for this project, and so we're here today to talk about the RCA's recently developed Introduction to On-Farm Composting Guide. So I'm going to read my spiel here to you now to give you a little bit of background and understand why we're here, what the background to the project was, what the thinking was, and then I'll pass it over to our speakers. So this project was undertaken in alignment with our goal to advance the circular economy. So the Recycling Council of Alberta is launching this document with the aim to engage farmers in composting. So the goal is basically to let farmers and ranchers and landowners know what the opportunities are to compost on their own land, to accept organics from municipalities, or to take compost or organic material from their own operations, compost them on site, and then reapply the material to their own land. Our hope is that farmers and landowners see the opportunity to diversify operations. Potentially there's an economic upside, as well as the obvious advantages of adding compost to your land and increasing fertility, increasing water retention, and all the good stuff that come with compost. So this project is funded by the Government of Alberta and the Government of Canada through the Canadian Agricultural Partnership. So we want to say thank you very much for the participation and the enthusiasm for this project. Once our presenters are finished today, we're going to take questions from the audience. So please enter your questions into the chat box as we go through, and we'll go through the questions at the end and make sure that we address anything that hasn't been covered by the speakers. Just a point of housekeeping, we also want to let everybody know that the presentation is being recorded today. So, you know, be aware. If you are not, if you're not okay with that, I guess don't watch. Don't say anything. I don't know. And then we're not 100% positive, but the goal is for this to be available later on. We have to get final approval on that, but that's what the hope is, that if anybody wants to come back and listen or see any of the presentations again, that this will be available. This is really exciting. I think this is the piece I forgot to mention is that there's a lack of compost capacity in Alberta. And so a big piece of undertaking this project was to say, you know, what are opportunities to increase that capacity and also provide some economic development and some opportunities for our local economy and our local residents in Alberta. So hopefully this generates some interest and some enthusiasm, because we're certainly enthusiastic and interested. So our first presenter today is Christina Seidel. She's the Executive Director of the Recycling Council of Alberta. She also holds a PhD in Engineering Management, a Master's degree in Environmental Design, and a BSc in Mechanical Engineering. That part I have to read because it's a pretty good list. She also operates Sonavera Group International, which is a consulting company in Alberta focused on waste reduction. Christina is a rural resident herself and lives on a farm near Bluffton, and I think enjoys her rural life and is definitely involved in the community. And I think this is pretty close to home for her. So I will pass things over to Christina and then introduce our next speakers as they come up. Thanks. You are muted.
Yes, I am not muted now. Sorry, I was so focused on making sure you could see the screen. So tell me you can see the screen. Okay. Brilliant. Okay, excellent. Want to make sure we don't have any technical glitches. So happy to be here. Thanks, Jeannie, for the intro. And I'm just going to give a brief overview of the project just to set the stage for the speakers coming next. So thanks everybody for joining. We have a great uptake on this webinar, which is fantastic. It's nice to see the interest in this topic. So this was something that the RCA had identified as an issue that we really wanted to help to address. And as Jeannie had mentioned, the base of the problem is that there is simply not enough composting capacity in Alberta to handle the programs that are really coming up rapidly from both municipal and ICI sources. So we recognize that there was a need to have more processing capacity. And we identified that one of the ways to do that is to link farmers more into communities. That also opened an opportunity then to collaborate with a number of different stakeholders. So as Jeannie mentioned, there are a number of benefits to composting that all of you are well aware of. So again, it's not just about getting waste out of landfills. It's much more importantly about really looking after our soil, and at the same time providing that additional benefit to farmers and farm operations. So our solution to this then was to develop a guide that landowners, farmers can use if they want to jump into this area. So the goals around this are basically within the guide to just demonstrate the value and the benefits associated with composting, and getting farmers to actually consider it as an add-on to their existing operations, and to help them then, if they are going to do this, what are some of the things that they need to consider and how do they get started. So in launching this project then, Jeannie had mentioned our funders, which we greatly appreciate, because this would not have happened without the Canadian Agricultural Partnership. So this has been a great help, particularly from Alberta Agriculture and Forestry, and certainly appreciate the assistance that they've given us. We also worked with Olds College initially. We actually had a couple of students from Olds College kickstart us by doing a case study. And the case study then was of perhaps our most important partner, which is Stickland Farms. And this picture shows Brian Stickland in the middle of the operation, an amazing facility. He has done an amazing job, and he is first and foremost a farmer, which I think is what has made his operation so successful. So we really appreciate Stickland Farms and the model that they have provided to show that this can be a very viable and valuable opportunity for farmers. So thanks to all our partners. And again, this just made it so much stronger to have all of these particular partners involved. So that's a quick intro of the overview of the project. And I am now going to turn it back to Jeannie, who then will introduce the next speaker.
Thank you. So our next speaker is Mike Dorion. His bio on the website says that he is also known as the Compost Kid. Mike loves food. He's passionate about food and about sharing and teaching the value of food farming and the importance of the land. Mike originally started a gardening class put on by the Calgary Hort Society, and then continued with a permaculture design certificate, spin farming, greenhouse design, compost facility operator certificate, and is mentoring in soil and soil microbiology. He's currently working on my soil food web advisor role with the, he's working on his soil food web advisor role with the Soil Food Web School put on by Elaine Ingham, and sits on the board of the Calgary Permaculture Guild. And we're very, very excited to have Mike here today. So welcome, thank you so much for joining us, and take it away, Mike.
All right. Okay, so we're gonna get into the why compost is important part. Now, why is composting important? Well, I would say like the biggest part of something that we need to look at is us being humans on this earth. We are the ones that have the biggest brains that are able to make all these crazy decisions of how we treat our soil and how we don't treat it. So we are basically the stewards of the land, and that is our job. And I think we've fallen a little wayside of that. So it's time to bring that back and make sure that we are taking good care of that, because, well, if we don't, then it's going to be really hard to grow food and be able to do the things that we need. So composting is super important. And so by keeping stuff out of the landfill, and I've always thought of, you know, if the farmer growing and putting so much time and energy into growing food, and then so much of it going to the landfill or being wasted, then if we can at least put some of that stuff back to the soil again, so that at least we can start to close that loop. Okay, now, if we look at this circular approach where instead of some of that stuff going to the landfill or whatnot, we can now take that and send it back to the farmer, who then can compost it, turn it into an amendment that's useful. And now we can turn that into the soil, growing good nutrient dense food that can then go back to that community that gave the food back anyway. So we can start to, instead of having these giant, large operations, let's have these little decentralized models that takes all the logistics out of the picture. And that way we can keep it a lot more sustainable. And then that way we can also then focus on the end product of making good, high quality compost instead of just processing waste.
Mike, we're not seeing your slides.
No? Oh.
If you want to,
sorry, I guess I should have asked that question from the
that's
beginning.
okay. If you want us to present, then we can do that too.
Sorry about that. How's this looking?
It's getting there.
See him now?
Yeah, there you go. Perfect.
Okay, sorry about that. So we were talking about composting importance. So you heard everything I said there. So we'll move to the few slides there, and then this is the circular portion. So where we're taking that food waste and bringing it back around to make sure that that we can close those loops instead of letting things go off to the wayside, getting that compost into the ground to grow that nutrient-dense food. Now, why is that important? Well, think about all that energy that goes up into a plant, and then we take that away. That plant typically wants to have all that energy to have babies and have seeds so that it can keep having its reproduction going. But then we take that away as the food source. Well, then we have to give back. So think about like a forest, for example. Nobody fertilizes a forest. So what's going on in that system that we could start to replicate in our own backyards, our own back 40s? And this is where compost becomes a really, really valuable tool to be able to do that. So we're giving back some of that energy that was taken away. Now, if we look at a little bit of a history lesson here, now, you know, because we keep taking away, and if we look at some of our organic matter levels from, you know, before kind of the green revolution and when farming became very industrialized, they were up into the mid-teens. And now we're very lucky if they're, you know, 2 to 3% organic matter. But if we look at the Chinese, for a long time, they were taking what's called the night soils. So another way of looking at that is human manure, or let's just say poop and urine. They were collecting it from their own people and putting it out onto the soils. So they were taking away for the food, but then putting stuff back again. And they've been able to be one of the few civilizations that have been able to farm their land as intensively as they have for as long as they have, because they have been giving back. So I like this little one off to the side. It's like the soil. It's saying, without me, humans could not exist. So we need to start to look at that relationship of what we're doing with our soil. And let's not just look into the next season or the season after that. Let's start thinking about our succession levels of what kind of land am I passing on to my kids or my grandkids? Where's that looking? So we need to start looking further ahead. Now, another reason is every time we're putting compost, really good, diverse compost into the soil, we're adding organic matter. So that's the one huge benefit of that. But when we're composting properly, we're actually producing a certain amount of organisms, the microbiology in the soil. I'm sure a lot of you guys have started to hear more and more about the microbiome in our gut systems. Well, this is essentially the probiotics of the soil. So when we're talking about this soil food web and all these organisms and the things that they're doing in the soil, they have a direct relationship of what is happening and cycling those nutrients and helping break down organic matter and turn it into nutrients and pass it back to those plants again. But they also have a bunch of other things that they're doing. We'll get back into in a moment. But these are just a few of these things that we need to look at. And the thing, because these organisms are microscopic, it seems to be this out of sight, out of mind, but the research that is coming out on this on a daily basis is quite huge. And there's a lot more impact that these organisms are having on our bodies and our soils and all around us, more than we give them credit for. So we need to start giving these little guys some credit, because I was always told to respect my elders, and these guys are ancient. Now, why about this soil life? Well, the research is showing more and more that most of the soil function that's happening below ground is responsible because of them. So do we want to live on Mars, or do we want to live on Earth, where we do have this relationship with these organisms in the soil? So part of what they're doing is, so they're doing that nutrient cycling, they're breaking things down, making nutrients available, water soluble, for the plant to be able to pull it up. They're keeping that soil aerobic as they're growing in population and moving and going through the soil. They're tilling it on a micro level, so giving us little pockets of air and little pockets for water to hold out to. And then as they're doing that too, they're actually holding those nutrients in place. So think of a bacteria that can reproduce every 10 to 20 minutes, and they grow into the billions of numbers. They're like little bags of fertilizer. And they're there to help and work with the plants. They're not there to compete against them. They're there as a mutual relationship. And so as they're doing all this moving around, they're starting to release these glues and enzymes and acids, and that's starting to build the structure of our soil. And we know that if we have good structured soil, then we're going to have really good air capacity in there and good nutrient retention. But the big one, and this is where I think we're going to be forced to be really looking at our soils a lot closer, is the water side of it. Now, if you've had a good heavy rain and it comes down and that water just pools there, starts running laterally into your ditches, it's pulling soil with it. We don't want that. We want it to soak in. We want to turn our soil into a sponge. We don't want it to be a brick. And compost is a really, really great way of doing that. Compost holds a tremendous amount of water. So for every 1% of organic matter that we can increase in our soil, we can hold up to 25,000 gallons of extra water. That's huge when we're coming into this huge kind of drought periods that we're having, and the weather is becoming a lot less consistent. So if we can have that sponge holding that water in our soil, then it's going to make our soil a lot more resilient. And then it's going to make our plants that we're growing in that soil a lot more resilient, because they're going to be able to have all the things that they need. Now, a little example, this is down in California, the Marin Carbon Project. I recommend you to research this project a little bit more. It was really interesting. So they took a bunch of food waste compost from the local municipality and put it out onto the rangeland, and 50% increase in their forage production, huge. But the real thing I want to point out is the increase in the carbon. So carbon is a big thing right now. Our soils can be treated as a sink. So if we can pull that carbon down out of the atmosphere and into the soils, that's going to actually help the production of that soil as well. And a big part of that is using compost. But when we put compost in there and it's alive, full of those microorganisms, those guys are going to come into the soil and start reproducing. So look at like a handful of soil, really good healthy soil would have 10 meters of fungal hyphae in it. Well, that's crazy to me, but that's all carbon. And now looking at the things that are coming on with carbon credits and looking at some of these new carbon cryptos that are coming around as well, this could be another revenue stream for our dear farmers that are busting their butts to grow food for us. And then this one I really love. This was done in Canada. Dr. Lord Abbey was conducting this one. And this was over 5 years where they were using, again, a municipal compost that they were putting out onto the field. So they were doing it annually. They were doing it every 2 years. And then they were just doing a regular control on basis of a fertilization program. And as you can see, the produce is definitely larger. But the real one that he was testing was looking at the nutrient density of the food, and it was through the roof. And this is something that we have to be very mindful of, because if we look at the research, our food is becoming less and less nutrient dense. We're essentially eating stuff. No wonder we're trying to just keep eating and eating and eating, because we're not getting the nutrients that we need to make our body do its thing. So if we can actually get good nutrient dense food, then it'll fill us, and that becomes that food is thy medicine. It will actually keep our system of our body running healthy. And I would love to see, instead of farmers being paid on volume or mass or by the bushel, if we could get farmers paid by the amount of nutrient density in their food, then that would be the direct way of making a farmer want to proceed with doing good soil health management, because then they would actually be able to get paid for what they're getting, for what they're doing and what they're putting that extra time into. So really, really great, great study that Lord Abbey was doing there. Now, just on the nutrient management plan side of things, so I know a lot of you are probably very used to following your typical NPK program with your synthetic fertilizers. And so compost is going to be very similar. You're going to be going out, you're going to be doing your soil tests, you're going to be making your plan, and then you'll apply the products appropriately. You're not going to be just going, oh, I'm just going to just pile all this stuff on like willy-nilly. You need to make sure that you're having a plan. Now, the bonus of this, though, is, with your typical synthetic fertilizer plans, is you're just getting those nutrients that you're putting on. But with the compost, you're getting so much more, right? We're getting that organic matter. We're getting our micros and macronutrients. We're getting carbohydrates, lipids, amino acids, all these things. And it's helping with our water retention, the nutrient retention, all these things, making our soil become that sponge so that we can grow really healthy organisms in it to then grow really healthy plants. And if we can continue in that mind frame of looking further down the line of growing really good, healthy soil using compost and other soil health tactics, then we're going to make sure that our soil is super resilient for the future, growing super resilient plants. And that is all I got to say about how compost has got to work. So thanks, Jeannie, and I'll pass this on to the next speaker.
Thank you, Mike. That was really helpful. It's a good reminder. It's always a good reminder to think about the actual nutrient value in food. I think it's something that, you think about, like you said, the size of produce and how much is produced and all that kind of thing. But the nutrient value is really interesting. And I think that the current weather situation is also a good reminder that the water retention is something we really need to be considering more than ever, right? Yeah.
Yeah.
All right. So that was an overview on the value of compost and how compost can improve soil health and help our plants and our farming. John Paul is up next. So John Paul is going to present sort of the concept of on-farm composting and where we're going with this and what the steps are that we are presenting in our guide here and what the implications are. John Paul has been involved in all aspects of composting, compost facility design, and compost use for almost 30 years. He was raised on a dairy farm in BC and has an agriculture degree from the University of Alberta and a PhD in soil science from the University of Guelph. He worked as a waste management scientist with Agriculture and Agri-Food Canada for 7 years and has been designing compost facilities since 1998. He has taught a compost facility operator course since 2006 and authored the Compost Operator Manual, acted as an expert witness in compost-related matters, and has participated in the development of composting regulations. He is clearly passionate about returning organic matter and nutrients to our soils safely and effectively. And with that, take it away, John Paul. Keep holding on to your questions too, everybody, because we want to go through and discuss benefits of compost, but also any questions you have about sort of the implications in the process afterwards. So make sure that you are either putting them in the chat box there or jotting them down for yourself. Are you there, John Paul?
There we go. Welcome, everybody. It's a pleasure for me to be part of this project, and thank you, Christina, for allowing me to be part of it. Thank you to Jeannie for the introduction, and thanks, Mike, for your clear demonstration of your passion for soil. Can everybody see my slides okay? So I'm going to invite you to explore what an on-farm composting project could look like. It would be an on-farm composting project that's importing off-farm waste, and part of that will be the slides or some photographs from Stickland Farms as well. So first of all, there are an amazing set of guidelines and regulations available for producers and composters in Alberta. There are the guidelines on how to compost, the nutrient management guidelines that Mike referred to as well, and then the guidelines and regulations around the compost process. So that includes the code of practice for compost facilities and also the standards. So there is really good resources available to go forward on this. The goal of the regulations and the guidelines is to help you and help all of us compost effectively, to minimize odor, to allow us to compost on an impervious surface to prevent water and leachate discharge, to protect our environment in that way, and to produce a safe and effective compost that minimizes the potential pathogenic organisms, to minimize the application of non-compostable material to our soils, and to manage and prevent elevated concentrations of trace elements. So that's part of the goals of the guidelines as well. So what could a compost process look like? I have a graphic of what a facility could look like, and there are a number of important areas that need to be included. So it's the goal of this process too is to help all of us understand what's all involved with the compost process. It's not just a matter of receiving material from our community partners. We must manage it carefully. So first of all, we need to have an area for receiving material and blending material. We need an area for bulking agent storage, and we'll get into that as well. We need an area for active composting, where all the exciting steam and primary decomposition happens. We need an area for curing. We also then need an area for screening, so take out the larger bits, and removal of non-compostable material. We need an area for storage of finished compost because we need to plan our application to the field accordingly. And we have to think about processed water capture. I can appreciate that's the last thing on our mind right now in dry and hot weather, but we do have rainfall, and we do need to capture that water that comes on our compost site. So a couple of questions when planning a compost site is, how will you protect ground and surface water? This can be done either with clay or synthetic liner, with asphalt, with concrete or roller compacted concrete. And also we need to think about how are we lining the processed water pond. We also have to think about a working surface. So although clay is a really effective barrier to the groundwater, it's not always an effective or a good working surface, particularly in spring and fall or during and after heavy rainstorms. What type of compost process will you use? A couple of options are turned windrow, which has been the most common in North America. And then the second one is aerated static pile. There's many variations of that aerated static pile. Or is there another compost process that you could be using? How will you remove non-compostable material? We have to accept that when we're bringing in organic material from our communities, there will be treasures in that material, including film plastics, shoes, whatever. How will you be removing this? Will you be removing it before or after the compost process? And then what process will you be using? Now I'm going to show you a number of slides and photographs from Stickland's farms, and to walk you through each part of the compost site, if you will. So first of all, there's an area for receiving material. The material received may include yard waste, source-separated organic waste from residents or commercial sources. It may include biosolids. It may include other woody material or agricultural waste. And it may then also include manure or other waste from the farm itself. This photograph here shows some of the incoming source separated material, where you can see there is a lot of non-compostable material. So we do, as farm operators who are composting, need an ongoing working relationship with our communities, because we want to try to minimize the amount of non-compostable material that we're bringing onto the farm. So then we need an area for preparing the compost mixes. So this can include mixing with a loader, a specialized mixer, or during a grinding process. Some of the materials may need to be ground or size reduced in some way. We need to prepare compost mixes for optimal composting. And generally we say our target moisture content, according to the Alberta Code of Practice, should be between 40 and 60% moisture content and less than 70 kilograms per cubic meter bulk density. And part of the reason for that is the composting microbes are aerobic. The ones we want to be encouraging are aerobic. They need oxygen, and we need to have air spaces or air-filled porosity in our composting mix so that the oxygen can get to it. We need an area for storing bulking agent, as we need to be blending other woody bits with our incoming food waste or biosolids, for example, because these materials are dense and high in moisture content. So again, we need to be blending what we call bulking agent in with that material to get that air-filled porosity. So the material that's used for bulking agent may include wood chips, bark mulch, or screened overs from the compost process. So essentially the overs that are recycled in the compost process. Then we have an area for active composting where the real excitement happens. Generally speaking, we have learned through our worldwide research that forced aeration benefits the compost process in two important ways. It speeds up the compost process, and it dramatically reduces the potential for odor. And what we've also found is that the combination of aeration and mixing provides the best quality compost in the shortest time period. So here we see one option, aerated piles with pipes underneath. This is from Stickland Farms. The aeration pipes can either be above or below the working surface of the site. The piles can be windrow shaped, or they can be extended piles, as we see in this photograph. The aeration blowers can be either controlled by timers or have a temperature feedback loop to maintain temperature at, say, 65 degrees Celsius. And temperatures can either be monitored with wires or with wireless probes. So there's quite a number of options here. Here's another example, and it happens to be one of my favorites because it's quite an efficient way of composting. And it's essentially an aerated static pile in the shape of a windrow, where it benefits from that natural convective air movement, where the hot air goes up, also draws air in from the side. There's what we call a bio cover over the pile, and that's also required as per the Alberta Code of Practice, and that biocover does two things. It insulates the pile so that we get better pathogen kill, and it also serves, it's demonstrated that the biocover is probably the best possible odor control mechanism in this type of process. What we do have to understand, though, is that when we do this active composting, we need at least one mix to get adequate pathogen reduction. Then going back to the curing site to help you regain the perspective of the various parts of the compost process, after we finish active composting, we have a curing process. And the curing process is like curing cheese or curing other products. The compost needs to be further cured to further stabilize the compost material. The curing part of the process does not need active aeration, but the microbes do need to breathe to allow the process to continue. So generally speaking, the area required for curing is probably at least as large as the area required for active composting. And then the next part of the process is screening. The larger particles and the non-compostable material has to be removed from the compost before application to the field. The screening can actually occur after active composting and before curing, or it can be done after curing and before application to the field. So there's a number of ways depending on your very particular operation. We need to think about the non-compostable material, and this has been the challenge for many composters around the world. We've been excited to start the circular economy, taking the organic matter and nutrients back to the farm, but it seems like we're taking other treasure with it, such as the film plastics. And it traditionally hasn't been part of the costing for the process, and so many composters have been surprised and perhaps disappointed at the cost that has to be incurred to remove this non-compostable material. So we need that ongoing collaboration, work with our communities to reduce the amount of film plastic that's going to the farm, and particularly with the increasing concern of microplastics in our environment, it does need to be one of our priorities. Fencing the site is important. A couple of reasons. One, we want to keep wildlife from the compost site, and this particular fox happened to be in a compost site in the Yukon, actually. And the second thing is it keeps film plastic and other material from spreading around the farm. So it's basically a safety net, so to speak. Well, then we have a finished compost. How do we value a finished compost? Well, I'm sticking my neck out and saying it has a nutrient value of up to $200 per dry ton, depending on the nature of the compost material. But as Mike had suggested, the value of the compost goes far beyond the nutrient value. When applying a compost to our fields, it must be applied to optimize the benefit of the nutrients in the compost for the crop being grown. That's part of the strategy for a nutrient management planning on the farm, whether it's with fertilizer, manure, or compost. And a gentle reminder that compost provides much more than simply the fertilizer nutrients, as Mike has presented. So in summary, returning nutrients and organic matter to the farm benefits our farmers, benefits our community, and it benefits our planet. Thank you very, very much. Turn it back to Jeannie.
Thank you, John Paul. That was great. So we have a bunch of time left for questions. I guess one of the things that we really want to just make a note of here, John Paul just did a great job of explaining what the steps are, I guess, sort of what the area that you would need to do on-farm composting on your own farm would look like, what the steps look like to some degree. The guide that we've put out, which I believe, I just got a note that it's actually been released today, possibly. We should get a thumbs up from Christina and Deborah here. The guide that we put out focuses on stickland farms, and the idea there was that the stickland operation has been operating in Alberta for many years and is a great example of a successful operation that has scaled up, in my opinion, pretty far. They're processing a lot of material there. And in speaking with Brian Stickland, we really got a great understanding of the benefits that he has seen on his own farm, right? Like he's not doing this as a feel-good activity. He's doing it because the compost is really valuable to him, and it's been he's realized some cost savings in terms of fertilizer, but also has just improved his crop yield. His soil health is really improved. So in our report, you'll find that there's a case study that really looks at that operation. I think we want to take some questions here. I think my question would be, if anybody's interested, what are the things that you think you would need to get up and running? I think that's one of the questions that we've had. We know that there's a piece here. We were sort of joking, we need to set up a dating site between farmers. This was Mike's idea. We need a dating site between the farmers and the municipalities, but we know that there's a lot of increased interest from municipalities across Alberta and Canada and elsewhere in collecting organics from just municipal organic waste, so food waste basically. There's the question of biosolids and how biosolids are going to be managed by municipalities moving forward. There's been a lot of discussion about that. So I guess on one hand, we've got a bunch of material to be processed and not a lot of processing capacity in Alberta. So that is the opportunity that we see here. All right, let's roll into some questions. There's a one here that we got a few minutes ago. I think that this one is probably going to head over to John Paul. It says, are there studies or knowledge already on setting a value on various qualities of compost? So it says, we provide a custom compost management service on farm throughout Alberta, and many farmers are looking to put a specific dollar value on the compost that's being produced for them. Can you speak to that, John Paul?
Yeah, I'd love to. Well, therein lies the challenge. And for having grown up on a farm and having many friends as farmers as well, the short-term need that I have is to get nutrients. So really, in the short term, I'm just going to value the nitrogen, phosphorus, and potassium. And the compost is going to be lower in nitrogen than we need. It's going to have probably lots of potassium and phosphorus. So I will need extra nitrogen fertilizer at the outset. But we have to, as Mike has so clearly demonstrated as well, we have to keep thinking about the long-term value of compost and how do we value that? And yeah, I would invite others to get involved in particular research on that as well, and maybe Stickland Farms, or I think he's seen a real benefit, and I've got other farmer composter friends as well who've seen much more than that immediate nutrient benefit to the compost. So we do have to put numbers on that. I threw out the value of $200. That's just a start. I wish I could give you a better answer.
And Jeannie, if I can just jump in quickly, we're actually looking potentially at doing a follow-up project with Olds College to look at exactly this, because there's so much we don't know about not only the value, but the actual other benefits that actually are a result in the soil itself. So, and that would be such a valuable educational opportunity for Olds College as well. So John, I'm sure we'll be calling on you as well to help us with that. So we are looking at that and hopefully going forward.
Great.
It's an interesting question too, because it makes me think about the market, right? And different markets are going to value different things in compost, right? You know, how it's being applied, what it's being used for, what they're currently using as an alternate. All of those are interesting questions. We have another question that says, will this initiative be primarily using the thermophilic composting technique? I have been looking into different ways to decompose waste and found a few options such as vermicomposting. Will these alternative techniques be researched and taught as well? I don't know, John Paul, you can answer that too. My initial response, just from a project perspective, is that we focused on the aerated static pile method because that's what is being done at Stickland Farms, and I don't think that this project will be looking at other methodology. But do you want to talk about, I guess, why we stuck with aerated static piles, John Paul?
Yeah. Thanks for the question. So the first part of the answer will be, yes, we should be thinking about vermicomposting and other composting methods. I've been growing worms and vermicomposting particular materials for some 25 years, and it's a fun and amazing process, but I'll just have to say it's a labor of love. It's a complicated and laborious process to do it well. So that's probably one of the reasons we haven't focused on it for this study. It's a little bit more challenging to run a compost operation year round with worms, particularly when it gets to -40. But love to see some more work on that as well. There has been very successful vermicomposting projects around the world, usually not on a really large scale as we're talking about with some of the on-farm composting, but there's some excellent models out there. Thanks for the question.
Thanks. Our next question is from Kim Rapidi, and it's very direct. It says, what is used as biocover for aerated piles? This multi-part, I'll read all of it and then I'll come back. Do they need to be watered? What's the capital cost of for the aeration equipment? And where can we find the guide? So the first one is, what is typically used as biocover for these piles?
So I'll address that. I think that's, so typically the biocover is the finished compost over. So the material after curing, after it's screened, the overs part of it, as long as the major of the plastics and other non-compostable material has been removed, makes an excellent biocover because this material would be alive with microorganisms. And if there are odor compounds seeping through the pile, if you will, the aerobic microbes in that biocover would take care of that really, really well. So the recommendation is about 6 inches or 15 centimeters of a biocover layer. It could also be wood chips. That's the two most commonly used.
The next question is, how do the piles need to be watered?
Watering, I think Kim knows, and many composters know that watering of a compost process can be particularly challenging because as the composting material dries out, it becomes hydrophobic. And so really the best way to water composting material is during the mixing process. Having said that, and just chatted with Brian Sticklands as well, what he's found and is similar to what many other people are finding, particularly with food waste. We've got to put a lot of air to it right at the beginning, and that's important to reduce the potential for odor. But when we're blowing so much air into it, we're drying the material out as well. So it's a balance. And so yes, typically during the mix process, we may need to consider at least one watering.
Okay, one more piece to that. What would the capital cost be on the aeration equipment? Do you have an idea of that? top of mind?
Well, the scientist's typical answer is it depends. But an aeration system can be very, very simple for small piles. If you probably didn't see it on Brian Stickland's photos, but some of the aeration blowers that he's been using are simply the air toy blowers, if you will. So they're can be very, very inexpensive. Piping, it's usually PVC or HDPE piping. And then the control system, a timer is the critical part of the process. So your total cost for an aeration system can probably start at $1,000 for a simple aeration system for a small facility, and can go up to well over $100,000 for a larger facility with computer control, temperature monitoring, etc.
All right, and the last piece of this I can answer. It says, where can we find the guide? So Deborah confirmed that the guide has been approved. We've been waiting on review from the Alberta government just to give us a final go ahead, go for it. So we'll be publishing this week. So check our website, and sometime later in the next couple of days, it will be available on our website. We have another great question from Peter Duck that says, whoops, it just moved. A number of the compost facilities in Alberta have been challenged with managing nuisances such as odor, fugitive litter, and offsite vectors. John Paul, can you comment on the ability of a well-run, well-designed compost facility to truly manage those problems, and whether there are examples of places where there has been successful cohabitation between one of these facilities and the neighbors, basically?
Yeah, that's a fabulous question, and it's obvious when we Google compost stink that we're going to get stories of compost facilities that smell bad. The one example I'll come back to is Stickland Farms. When Brian first started, almost 10 years ago, he just did a compost pile, and it was more a passive pile with maybe some turning. His neighbors knew all about it. And so when he transitioned to an aerated process, his odor concerns dramatically reduced. What he's found since then is, as I mentioned earlier, the initial part of the compost process. So when the food waste is first delivered, put into the compost process, if a substantial amount of air is delivered to maintain high oxygen concentrations, the potential for odor is pretty much gone after a couple of days. So it's through good management, so best management practices. We don't necessarily need to have compost facilities completely enclosed to be successful, but we do have to understand the compost process, the importance of aeration, and the importance of oxygen, and then the importance of that bio cover on the material as well as this time of year as well. We have a lot of warm material coming to our farm that's already partially decomposed, and it has odor right when it arrives at the farm. So it does need to be blended and turned into the process quickly. So that's one of the keys as well.
I'd just like to add on that too, John Paul, is Alberta Environment is also revamping their guidelines and everything as well too, and they're becoming a little bit more stringent on the process of allowing the facilities. So that's going to help with, I think, how they're managed and stuff as well.
Yeah, that's great. Thanks, Mike.
I wonder, Mike, too, if you can comment on sort of the social side too, in terms of perception around composting. That's the sort of thing that you, I think, deal with a fair amount, and I think it has a strong influence. Yeah,
I think because the term compost is thrown around very loosely and it's quite general, just the education that we still need to keep showcasing people, because like Composting can be done very many different ways. There's lots of different feedstocks and stuff that can go into the compost, and it can be used for different things, right? So I think as long as we keep pushing on the education side and make sure that we have these open conversations between the facilities and the people that are providing the feedstocks for those facilities, and then the people that are using that finished product, I think then we'll be able to make sure that all parties are pretty happy.
Thanks, Mike. I have another question for you here. I'm not sure if you have an answer to this, but there's a question that asks whether any jurisdictional information is available or comparative analysis about what other provinces are doing right now and with relation to composting. Either, I would say, she didn't ask this, but I think there's sort of two scales of composting, which are an important question, right? There's sort of large scale municipal programs, or what we're talking about here, which would be a smaller kind of on farm or sort of sub 20,000 tons per year type of program. What? Yeah.
You asking me?
Yeah, I'm asking.
Wow. Okay.
I'm looking at you on my screen.
Right. I can't tell. Yeah, no, I think that's if you look, so the Compost Council of Canada, who is essentially the regulator of what's going on for composting in the country, and making sure that regulations and education and all that stuff is staying on board. They do have some really great resources on their website, compost.org, if people are keen to see what different provinces and stuff are being held up to. But I would say that has been probably the biggest issue is looking at these larger facilities, and they're very good at processing waste, but is their main focus at making that product at the high product at the end. And so the Compost Council, with a lot of their partners and members, are looking at different ways of trying to scale that down and look at more of these decentralized models and getting more of that circular economy thing going, where we can then focus more on making a high quality product. And then that way that whole system is being managed a lot better, and we'll be able to get a lot better results in the long run.
I think one thing to add to that from an Alberta perspective is that my understanding, and correct me if I'm wrong, John Paul, but Alberta has pretty much the lowest capacity right now to process organics. Maybe not the lowest in Canada, but on the lower side. Like there's a lot of compost facilities and anaerobic digestion facilities and other processes that can manage organics in Ontario and Nova Scotia and BC and Quebec and I believe New Brunswick even. Alberta is definitely behind there, and that's where, I mean, that's why this whole conversation is happening, is that we've got a whole province full of municipalities who are interested in diverting organics, and we basically have, one sort of municipal facility right now, and then a couple of smaller ones, but that's about the end of the list, and it's a big province, so that's why we're having this conversation. The other question is what type of funding is available for municipalities and how can municipalities participate? Do you have thoughts on that, John Paul? That is something that that I think that we need to sort of dive into a little bit deeper. But I do know that there is, I mean, from my other life, I know that there is a lot of funding available for different kinds of infrastructure projects. Do you have examples, John Paul, that you've encountered?
Yeah, the initiatives in various places can be around climate change. And so, for example, British Columbia has had money available from the province as well as from Canada as part of the Paris Agreement to reduce greenhouse gases. So we know that diverting organic waste from landfills, if we're doing it properly, will reduce the greenhouse gas emissions. So there's a saving to be had there. And to meet our climate change targets, there has been money available for some of that in some areas. So that's one source of funding. We also would like to recognize that partnering with farmers on this kind of initiative is probably going to give us a lower capital and operating costs. So it may translate into better economics for our communities rather than the communities building the compost facility themselves. So there's not only the funding approach, but it can be cost effective to develop that relationship, as well as, of course, the bigger picture. This is good for our soils and it's good for our planet.
Thanks. We have a couple more questions here. There's a question that says, what are the restrictions imposed on farmers to accept biosolids from municipalities? And does this create a challenge for municipalities wishing to decrease hauling costs to facilities which do accept biosolids? John Paul, do you have an answer to that? Or Mike, are you aware in Alberta whether there are any specific restrictions related to biosolids?
I can address that. I'm not aware of any restrictions regarding biosolids. There are certain criteria that have to be met with food waste composting as well as with biosolids composting. We want to accept and recognize that not everybody in the world wants to see biosolids recycled on soils for various reasons, and we have to accept that ongoing question as well. But there has been a lot of research that really recycling that organic matter and nutrients back to the soil is really, really important. So at this moment in Alberta, there are no restrictions.
Thank you, John Paul. We're at time here. I just want to, that's right? Am I correct? Nodding. I want to say thanks to everybody. I think one of the things that we'd like to hear too, after everyone's had a chance to look at the guide, is to understand what you need from us. I mean, we're sort of looking at what our next steps are for this project, and we're not, we've had a little bit of back and forth and brainstorming and ideas about what might be beneficial, but it would be really, really great to hear from farmers and municipalities and anybody else interested on what other kinds of information you're looking for, or where we could play a role in supporting. So please feel free to reach out to myself or to Christina, and we'll be in touch. Keep an eye out for the report. It should be out there in the next couple of days. Thank you, everybody. Do you have any closing words, Christina?
No, just thanks everybody for the great interest, and yeah, we're really looking forward to where this goes. We're very excited about this guide, so really would love to hear your feedback. Thank you.
Okay, thanks. Thanks, Mike and John Paul.
Thanks, everyone.
All right. Bye-bye.
Thank you.
Bye.